Hello, everyone. My name is Mark Hogue, and I'm an assistant professor at Slippery Rock University in Pennsylvania. The title of my presentation is the use of video-based instruction in asynchronous online mathematics methods classes for pre-service teachers, a quantitative exploration. Just as a position to focus the talk, it's important to point out that we have seen within the parlance of the COVID pandemic and just the evolution of online learning in general, that there is an increased need to really study and look at the work that takes place within asynchronous classes in delivering pedagogical practices that really meet students at their needs. And the focus of this presentation is to really explore that in a quantitative fashion. We have seen for quite some time the literature discuss that technology for technology's sake is not a sufficient solution to meeting students at their level of need. We need to really have engaging ways to develop students through a platform that allows them to be very, very much hands-on with the material and engage with the instructor. So one of my guiding questions as I look at this particular problem of practice for myself is how can the use of an instructional strategy, and in this particular case, a video, really promote student learning experiences consistent with impactful learning. In this particular case, I looked at 230 graduate students enrolled in the same math methods class for future elementary school teachers, K-6 math methods. 95% were seeking initial certification in elementary education or special education. This was a compulsory course for students seeking certification in elementary or special education. Now, of the 11 sections that were featured in the study, each consisted in over the course of an 8-week term. It's important to also point out that as part of the course requirements, students were required to complete 2 lesson plans as it relates to their work with course content within the scope of a standards aligned lesson plan. Those 2 lessons could be discrete topics. They weren't linked or sequential with one another, but just again, 2 lesson plans covering K-6 math content. Students were required to use a particular template that provided written instructions and also prompts, as long as a detailed rubric related to how they would be graded on the preparation of their lesson plan segment. Now, it's important to point out that these lesson plans were due in weeks 4 and week 6 of the class. And between those 2 submissions, the instructor was able to provide feedback on the first lesson plan. So as students moved into their preparation for their second submission, that they had that feedback to work with. Now, when we talk about the intervention specifically, in other words, what changed or what made this particular study focused on a stimulus, that was an instructor-created video segment. And this video was approximately 20 minutes in length, and it talked about best practices and really an explanation of the expectations for the lesson planning process, again, lasting approximately 20 minutes in length. And this video, again, was shared with students at the beginning of the class so that, again, on some level, they had access to this intervention for both the first and the second lesson plans. Now, in terms of our control group, our control was 7. So we had a total of 11 sections. Our control was the first 7 sections that did not have access to the video, and the treatment was the 4 remaining sections that did. This amounted to an observational study. Again, random assignment was not utilized. This was an observational study, but looked at approximately 230 students. Now, we mentioned that there was an instrument used, and this instrument was based upon NCTM CAPE standards, and we looked at, again, 11 reporting categories, and specifically within those 11 categories, there were 3 different measurement levels: target, acceptable or unacceptable, 10 points, 5 points, 0 points. giving us a continuous variable in terms of the reported score from 0 to 100. Now, as we get into the null hypothesis, we're making the assumption that there is no systematic measurable difference between those who had access to the video and those who did not. Now, let's spend our time really getting into the data analysis. So we can see here that figure 1 shows the mean for each section plus or minus 1 standard error. Control sections are in blue with circles for the mean, while treatment sections are in red with crosses. All 4 of the treatment sections have a mean score of at least 100, while 6 of the 7 control sections have mean scores below 100. Overall, students in treatment sections score 4.6 points higher on average compared with students in control sections, and this difference was statistically significant with an F statistic of 12.85, p-value of less than 0.001, using an analysis of variance that allowed for both variation between sections and variation between students within sections. The average variation between students, the root mean square error, was 9.2. Variation between sections was not measurably larger than 0. In other words, we did not observe that students in some sections appeared stronger compared to students in other sections. As far as scores in lesson plans 1 are concerned, the students appeared randomly assigned to sections. In summary, the video intervention was associated with an average increase of 4.6 points on lesson plan 1, about 1 step on the actual measurement instrument, or I should say the rubric. Now, figure 2 shows the corresponding data from lesson plan 2. By comparing figure 2 with figure 1, we can see that all sections tended to have improved scores on lesson plan 2. As we would hope, students are doing better with practice. The standard error bars also appear smaller. In figure 2, the difference between control and treatment sections appear larger, since every treatment section has mean scores higher than the control sections. Now, using the same analysis of variance model from lesson 1, students with access to video scored statistically significantly higher compared with students from control sections. That is actually a p-value, or I'm sorry, an F statistic of 27.6 and a p-value of 0.001. The difference averaged 6.1 points on lesson plan 2. Once again, variation between sections was not measurably greater than 0. Variation between students on lesson plan 2 was 8.3 as measured by root mean square error. Now, this is where we're going to spend some time. Figure 3. These results give an overall summary for each section, but do not really tell us whether some students benefited more from the intervention than others. To examine this question, we compared the lesson 1 and lesson 2 scores for each student. These are not pre-test and post-test scores, since the intervention was applied to preparation of lesson plan 1, but we can assess how treatment group students who struggle with lesson plan 1, for example, fared in comparison with similar control group students. Now, figure 3 shows for each student their lesson plan 1 score horizontal on the horizontal axis and the lesson plan 2 score on the vertical axis. Now, control students are plotted with a blue circle, while treatment group students, as we've seen in the past, are plotted with red crosses. Now, since the score for each lesson was defined in steps of 5 points, many students had the same pair of scores. That's why you're going to see tight clusters. However, to separate them out in figure 3, a small random number was added to each score for display purposes only. This is a technique known as jittering, and you can reference Cleveland and his work in 1985 related to that technique. Now, a solid black vertical line at 110 shows the maximum lesson plan 1 score, and the solid black horizontal line at 110 is the maximum lesson 2 score. Now, notice there's a cloud of both treatment and control symbols at the coordinate 110, 110. These are students with perfect scores on both lesson plan 1 and lesson plan 2. There is another solid black line going diagonally from 60, 60 to 110, 110. Points above this diagonal line indicate improvement from lesson plan 1 to lesson plan 2 score, while points below indicate students with a decrease in lesson plan 2. Now, the dashed red and dotted blue lines will be explained in just a moment. The goal is to measure the effect of the video intervention on lesson plan 2 after taking into account each student's score in lesson plan 1. It's very desirable to know whether the intervention had a similar effect for all students, or did stronger or weaker ones experience more improvement. In other words, given a student's performance or score in lesson plan 1, what is the average improvement seen in lesson plan 2? This question can be modeled with an analysis of covariance. Now, before we continue, we need to consider that there were 57 students with a perfect score in lesson plan 1, 26% of all students, and these students appear in figure 3 along with the vertical black line of 110. Many of them also scored 110 on lesson plan 2, forming a cluster of points at coordinate 110, 110 on the graph. So the main treatment effect in an analysis of covariance assumes a constant effect for every student in the treatment group. But this is impossible since a student with a perfect score in lesson plan 1 cannot possibly show any additional improvement. The measurement instrument is, in this case, effectively maxed out. So we shall model our treatment effect in advance as having two components, a main effect and an interaction effect with lesson plan 1. What this means is that the size of the treatment effect is assumed to change depending on the initial lesson plan 1 score. What we are doing is fitting one straight line to treatment subjects in figure 3 and another straight line to control subjects for any score on lesson plan 1 on the horizontal axis. The vertical difference between the dashed line and the dotted line is the estimated effect of the video intervention. Just as for earlier statistical analyses, the analysis of covariance model included terms to measure the amount of variation between sections and variation between students within sections. The analysis of covariance variation means variation or variability after accounting for each student's score on lesson plan 1. It's important to remember that a treatment effect is now improvement in lesson plan 2 and over and above the score in lesson 1. So any effect of the video intervention in lesson 1 has already been removed. After taking into account lesson plan 1 and its score in the analysis of covariance model, variation between sections in lesson 2 was again estimated to be 0. However, variability between students on lesson plan 2 score after adjustment for lesson plan 1 score is now 6.7 points. Since all three analyses have shown no systematic variation between sections, for simplicity, we drop those terms for the analysis of covariance model. This is supported by the literature. The analysis of covariance model shows lesson plan 1 score was a strong predictor of lesson plan 2 score, and as we would expect with an F statistic of 121.37. After adjustment for lesson plan 1, the treatment effect was statistically significant. In other words, the dashed and dotted lines in figure 3 had statistically significant different slopes and intercepts. This means that the estimated treatment effect for students varied depending on their initial score in lesson plan 1. The treatment effect for selected levels on lesson plan 1 appears in table 1. Now, the video intervention had a beneficial effect for weaker students, those starting out well below the perfect score of 110. Students with an initial level of 75 improved about 10.6 points on average if they had access to the use of the video. Intermediate students with an initial level of 90 improved about 6.7 points on average. Now, one might be tempted to conclude from this analysis that the video provided hardly any benefit for those with the perfect score in lesson plan 1. This is, however, an artifact arising from our decision to model treatment effects with straight lines. As we noted before, many students in both control and treatment groups had perfect scores for lesson plan 1 and 2. So the lines estimated for treatment and control will necessarily both come very close to that cloud of students at coordinate 110, 110, resulting in a treatment effect of 0. Put it another way, a student starting with a perfect score of 110 on lesson 1 cannot improve on lesson 2. His or her score on lesson 2 will either remain the same or in effect decline. But we can now show that students with access to video 2 intervention had benefit when preparing lesson plan 2, even if they had a perfect score of 110 on lesson plan 1. There were 22 students in the control group with a score of 110 on lesson plan 1. Of these, 36% or 8 students received a lower score on lesson plan 2. There were 35 students in the treatment group who got a 110 on lesson plan 1. Of these 35 students who saw the video, only 2 students, 6%, got a lower score of 2, a statistically significant difference compared with controls. That's a chi-square of 8.77 with a p-value of 0.005. We can conclude then that the video had a reinforcing effect even for the strongest students in the study. Now, as we look at results, it's important to point out that there are a multitude of factors and potential confounding variables that can impact the effectiveness of online teaching and learning. I hope for sure that we are situating ourselves with that perspective. However, it's also apparent and very appropriate to point out that an embedded video, while not exactly an earth-shattering development, may provide instructional benefits for students. It's important to just point out that small objective evaluations such as this really support the efforts to improve an online class and online teaching methods. So this idea of continuous improvement is something that we see a lot in manufacturing. However, I think it's very important to point out that these small steps can also be taken within the context of course development and truly add a significant difference related to the quality and overall impact of your class. Now, these efforts can also be applied to various teaching methods and teaching practices. And the idea is when we can take measurable steps to not only take the approach of developing and refining our classes, but also take pause to collect data and analyze this data, we're taking a very strong step forward in producing course content that's going to be impactful for our students. This is one, again, that is very much an ongoing and organic process. Now, again, just as a moment to discuss limitations here, this is an observational study. Now, we certainly acknowledge that there is a tremendous amount of resources that goes into, in some cases, random assignment when it comes to the actual assignment of students into various sections, et cetera, related to our controls and our treatments. That again, this is an economical process to study a problem of practice. And it has, again, a tremendous advancement and benefit for allowing us to organically study a problem of practice and allow us to take measured, a measured understanding of how we can potentially take our instruction and improve it through the use of various instructional tools and strategies. Feel free to reach out if you have any additional questions. Again, my name is Mark Hogue from Slippery Rock University in Slippery Rock, Pennsylvania, USA. Thank you very much.